So our first one is a bit of revision from last year. So the basic concept of an inverse function. What is a function? Well, a function is decided to take a value here in the domain, you enter into the function and we'll map it to a value in the range. So every value in the domain needs to be mapped to a value in the range. That's what a function does. So you get a rule that will make this link or relation of some kind. So for the function to be invertible, what the inverse does is the inverse function, you should be able to give a value in the range of the original function, and it will give you the associated value in the domain that is linked to. So the basic idea of an inverse function is that the domain and range switch places. So the domain of the function is the range of the inverse. The range of the function is the domain of the inverse. So the domain here is the range of the inverse, of the original function. So the domain of the inverse is the range of the original function. So what value would minus 3 be mapped onto by the inverse function? It's in it.
0.
This one's going to map onto 0. And how about 2? 1. So the domain is mapped onto the range by the function. Those get switched around for the inverse function. So here we have f inverse. This is f inverse. So here, if we wish to sketch a function, we'll just do one of these. In order to sketch this function, we want to find some values. We want to list the key values of this one. So if I just count 1, 2, 3, 4, 5, 6, this is minus 6, 1, 2, 3, minus 4. This is at minus 6, minus 4. This is going to be at minus 4, 0. This is going to be at minus 2, 1, 2, 3, 4, minus 2, 4. This is going to be at 0, 5. And this is going to be at 1, 2, 3, 7. So we can see what the domain of the original function is. The domain of the original function is going to be, the domain of the original function is going to be from minus 6 to 3, like this. This is the domain. But a subset of that would be these particular values. A subset of that would be minus 4, minus 2, 0, and 3. This is a subset of the domain. It's not the whole of the domain, just part of it, a subset. In fact, 3 isn't in the domain. 3 isn't in the domain. This one's not in the domain. This is an excluded point. So the range is going to be minus 4, 0, 4, 5, and also 7 isn't in the range. It's an excluded value. It's a point of discontinuity, or the end point. It's excluded. These values aren't in there, but they're useful to us because what we want to do is if we switch these around, it creates a whole series of points. We want to plot minus 4, minus 6, 0, minus 4, 4, minus 2, 3, 0, and 7, 3. Let's plot these coordinates so that we can sketch the inverse. So we need to have a point at, I'm going to have to rub this off a little bit. We need to have a point at minus 4, minus 6. So here it's going to start. It's going to go through 0, minus 4. So it's going to cross through here. It's going to go to 4, minus 2. So 1, 2, 3, 4, minus 2. It's going to go there. It's going to cross the x-axis at 5, 0. It's going to cross the x-axis here at 5, 0. And it's going to end at 7, 3. So 7, 3. Take our ruler. And we can draw our function. Like this. This is the inverse function. And this is how we can plot an inverse function. What we notice, and what's really important about the inverse function, is it is symmetrical reflection in the line y equals x. This is the line y equals x. So if you notice, you can see that this is a symmetrical reflection in the line y equals x. If the original function passes through the line y equals x, the inverse will pass through it at that point as well. So these are good points to plot when sketching an inverse. These are good points to plot. We're not going to do this. This is a revision, so you did all of this hopefully last year. IM2. These are the slides from my IM2 regular class. So a little summary is the vertical line test. You remember the vertical line test?
Yeah.
To determine if it is a function. So if you can draw a vertical line at any point in the domain of f, and it crosses the function at most once, it doesn't have to cross the function. But I guess it's in the domain, it's going to cross the function. If it's in the domain, it's going to cross the function, yeah. So it has to cross at least once if it's in the domain. Only once. Only once. So if it's in the domain, it's got to have a point, so it's got to cross it only once. The horizontal line test is used to determine if a function is invertible. So if you draw a horizontal line at any point in the range of f, and it crosses the function, it can cross this one. So if you can draw a horizontal line at any point in the range of f, and it crosses this works too. Sorry, I'm just thinking through the extreme cases. So this means it is invertible. All right, our warm-up question for you guys today is to find the inverse of this function. I'll pause the video a moment. Okay, firstly, we need to sketch the function. Sketch the function. How does it look? It's going to go through here at 0, minus 5. And it's going to look like this. It's going to go through here at root 5. And here at minus root 5. Pretty easily see these 3 points, the roots, the exit and y-intercepts for this function, and we can sketch it. Is this a function?
Yeah.
Why?
Sorry? It passes the vertical line test.
It passes the vertical line test. Is it invertible?
No.
Why not?
Because if you do a horizontal line test, you'll see you will pass the function twice in one point.
This is not invertible. How can we... Oh, not quite horizontal. Let me stand straight in front of the screen.
So then it doesn't have a...
So, it's not invertible unless we restrict the domain. What is the biggest possible domain that we can have so that the function is invertible? Sorry, let me go for firstly. Currently, what is the domain of the function?
X is between the minus infinity and infinity.
Is there a bet? Can we not write like this?
Yeah.
It's all real numbers, isn't it? That's it. What's the biggest possible domain we can create such that the function is invertible? No.
X is part of the real, complex numbers less than 0 or greater than 0 at the same size.
It's not going to be complex.
Does not include like everything. What do you say? Yeah, you'll read it.
This would be the biggest possible domain such that the function is invertible. And what happens is we remove this. This function is invertible. This function is invertible.
Would you be allowed to say the opposite?
Yes.
Say x is
Yes.
less than or equal to 0?
If you wish to spoil my next question,
Oh,
is there an alternative answer to this? Yeah, you could point x in the x is less than or equal to 0 would also create the largest possible domain for which the function is
So
set.
both are correct.
Both are correct answers. They produce different inverses, and you have to be a little clever on that one.
The inverse will be the same, but do you have to
No,
always
the
remove?
inverses would be different.
But do you always have to remove the side?
No, the question might give you some clue on that one. So if I wanted to sort of feed you in that direction, I might have you calculate a value on the inverse that I'm looking for. So I would have you calculate a value which is here on the inverse, and then say, create an inverse for which this point is included. And then you've got to think, I need x is less than or equal to 0, and then you've got to change how you do the inverse slightly.
So the original function passes the horizontal line test and it's inverted.
Typical functions for this are rational functions.
Can it?
So now with the domain restricted, what is the range?
Then it can't be
Y is greater or equal than -5, and y is a real number. That's the range. So we switch the domain and range. So what we can do for this function is, if we switch the domain and range, we would say that x is equal to y squared minus 5. This is the inverse relation. This is the inverse relation. This relation defines the inverse. So once we switch x and y, we're changing it to an inverse relation. This is not a function. This is not a function, but it is an inverse relation. We need to get a function now. We get a function by rearranging it for y equals. So we just have to rearrange to get y equals. This gives us x plus 5 is equal to y squared, which means that y is equal to the square root of x plus 5. So that's our inverse function. Our inverse function is going to look like this. And they're going to go through this point here. That point is going to be 1, 1. Oh no, it's not for this function, sorry, it's shifted. But yeah, we will share it.
What are the green and red bottom lines?
Vertical line test, horizontal line test from a previous bit of me going waffle. Thank
How is the 0 for the first original graph?
How is the 0 for?
The square root of 5 is the x is that's the 0.
So the brings 5 over to negative 5 and it's to get x equals to 5. Did you do this one this way?
No, but 0.
That's the inverse function, isn't it? Okay. So our final answer we have to write as f inverse of x using function notation. The answer has to be given using function notation. So here is our final answer. Make sure you write your final answer using function notation, otherwise you lose a point. F inverse, or f to the minus 1 of x. F inverse of x is how we might say it awkwardly. And that's our inverse function for this one. Have a go at this question for yourself. I shall pause the video. Make sure you restrict the domain. Okay, so let's start off by sketching the function. Start off by sketching the function. What are the coordinates of the vertex of this function? 3, 2. That's here, isn't it?
Yeah.
This is 3, 2. Is it a sad face or a smiley face? It's a smiley face. What's the y-intercept?
Plus 2.
It's 11. Why is it 11?
Because you're on 0.
So that's how the function looks. So what does the domain need to be restricted to? What value? So the vertex is essential, isn't it?
Yeah.
For this question. You want to know where the vertex is. What's the range? So we need x, our inverse relation is this. So then if we try and move it around, we get x minus 2, or the root of x minus 2 equals y minus 3. F inverse of x is equal to 3 plus root x minus 2. You can't use the plus and minus in this one because you have to make a function that, yeah. Unless you restricted the domain in the other direction, and then you would use minus. You can't use both. Right, what is the domain of the inverse function?
Greater than minus 2.
This is an easy question. You don't have to work it out and think. Don't look at the function for the f inverse and think. Look here and just write it down. So the domain of this is that x is greater than or equal to 2. And x is an element of the set of real numbers. The y value, or the range, is greater than or equal to 3. Remember, the domain and range switch. You can use this for some very quick and easy problem solving strategies. If you can't find the inverse, but you have the original function, you can use that to find values on the inverse, and vice versa. Not particularly for this question in the way that it's worded.
Is it not like cut in half? You're not visualized.
Yeah. So what we've done is we've restricted this function, and this is the function that we're invoking.
So where is the range be different? Why isn't it different? The range is the same.
It's always, well, in this case, it's up from the vertex. So all the values are up from the vertex in the original function. So the domain is all the values up from the vertex of the graph. And the domain of the original function is all the values positively from the x value, and the range is the same one. So domain and range should simply switch. They're always identical. Okay. Show that question. How do we do a show that question of this type? We do a left-hand side to right-hand side, and what we use is we need to, like with the odd and even functions, there's a definition of how we define an inverse function. So we define an inverse function by saying that all we have to do is show that f to the minus 1 of f of x using function composition is equal to x. This is our formula we use for defining whether a function is an inverse. It doesn't matter in the order in which we compose those, it's still going to be x. So you can compose the two functions either as f of minus x, or f of minus x of f inverse of f of x. We've got f inverse of f of x. you could write this as f inverse of f of x using composite function notation. Also accepted. I like this way of writing it. So left hand side equals f inverse of f of x. So f inverse is this one. Here is where we can put our x. So that's how f inverse looks. Instead of x, we're sticking in f of x into this hole. So we've got x minus 1 squared plus 5 goes in there. Opening up the bracket, we get x minus 1 squared plus 5 minus 5, which is x minus 1. I'm doing a couple of extra steps here, showing it very clearly. This is how we can prove a function is invertible, or is the inverse of another. Any questions? We're starting to see this left-hand side, right-hand side strategy, getting a bit more comfortable with it, hopefully. All right, so are we ready to move on? My sense of thinking. Our question surfacing. Okay. I wouldn't expand I wouldn't expand this, because that's just going to be you're going to have to factor it back in again anyway. Very, very foolish thing to do. But when we open up this, because you get to this point here, where the square and square root cancel each other out, because they're inverses of each other.
How does x minus 1 plus 1 equal x? Use the square root of 5 and then plus 1.
So here we've got x minus 1 plus 1.
Right.
Minus 1 plus 1 is 0.
Yeah.
Okay, let's move on. Have a go at this question for yourself. I shall pause the video, which I paused it a while ago. Okay, what we want to do is we want to use this idea that if f of x is equal to y, then f inverse of y is equal to x, where x and y are the same ones. What that means is if f of x, if we need to find f inverse of 12, then this implies what we need to find is 12 is equal to x plus 4 squared minus 13. Okay, look where I put the 12 and why. So instead of finding the y value that this x value produces, make it a y value for the original function and see what x value would have produced that. So we set this equal to here, moving that across we get 25 is equal to x plus 4 squared. Taking the square root we get 5 is equal to x plus 4. We need plus minus, but once we consider the domain given here, we can reject one of the solutions. So this would give us x is equal to 1, because if we were to use the minus 5, that would give us minus 9. And minus 9 is not in the domain of the original function, so that would not be the correct answer.
For full marks, would you have to show the plus minus and like write an explanation for why you only?
I probably wouldn't at this level. But why not? It's better to consider it for a minute so you don't miss it. I like to add the plus minus here on this one, because it's only when I'm taking away 4 from both sides I see that you get 1 and minus 9, and then you know which one to reject easily here. I point this in the other direction. So I think it's useful at that point to write it, consider it, and then write the correct one. Rakoya, did you have a follow-up question? It's quicker just to do it like that, isn't it? Anna.
So f of minus 1 is equal to the x of the original function, right?
Yeah. Okay, you can solve this question by finding the inverse and then sticking it in. You'll get full marks, but you'll waste time. And if I didn't give you the rule, if I'd given you a graph and asked you the question, you have to just read it off the graph and say, yeah, that's it. All right, have a go at this problem. This one's a little trickier. I'll pause the video for a while. Ways to solve this problem. Probably the best way is completing the square. So that's what we'll do. So we've got f of x is equal to complete the square, you take this number, we've got x minus 5 there, and we halve it. Put a bracket around, square it, and then we take away that number we just made square, and then anything else that's included. This is going to give us x minus 5 over 2 squared minus 25 over 4. So this 5 here, give it a common denominator, so multiplying top and bottom by 4, we can write 5 as 20 over 4. So we see at that point that in fact, in completed square form, we get minus 5 over 4. Here we can see the coordinates of the vertex, so the domain needs to be restricted to x is greater or equal to 5 over 2. What is the range? What is it? So we can restrict it and we get our answer there like that one. So that's method 1. Method 2 for the same part of the question. So I can't recommend more than learning to complete the square. It's pretty easy. We've got a 5 here. So we've got minus 5 here, so we need minus 5 over 2 inside the bracket. We then need to take away that which we've added, which is minus 5 over 2 squared. Easy. Some of you are still struggling with that process. If you're stuck, you can always use a different strategy. We need to get it into vertex form. So you can get it into vertex form by finding the coordinates of the vertex. With this question, we can use that the x of the symmetry line is equal to minus b over 2a. So this would be minus b would give us minus 5 over 2a, which would give us 2. So there we see what we're going to have inside the vertex. That's the x coordinate of the symmetry line. The y coordinate of the symmetry line is going to come from f of 5 over 2. So we put this into the function. We get 5 over 2 squared minus 5 times 5 over 2 plus 5. 5 over 2 squared is 25 over 4. This is going to give us minus 25 over 2, which is minus 50 over 4. And this is going to be 20 over 4. So adding those together, we get minus 5 over 4. So we can then write the function in vertex form because we have the x coordinate of the vertex and the y coordinate of the vertex. So from this one we could say f of x is equal to x minus 5 over 2 squared minus 5 over 4. You get to the same place both ways.
Do we have to know the second method or?
No. No, the first method is the best method. The second method is acceptable. I think it's useful to know both methods. It's straightforward understanding. I would know both. Let's say, for instance, you've got some nasty a value at the front of your function. In standard form, your ax squared plus bx plus c, the a is 0.317. But then when you stick it into the calculator, it comes out as a 9. It's good to know the other method. It's useful on the calculator, the other method. So although I've done it here by hand, this method on the calculator is easy. And let's say you have some radicals involved in that. And if you're calculating exact arithmetic, it's going to still work. So both methods are beautiful. Beautiful methods. Okay. You need it in vertex form to find the domain. You need it in vertex form to find the inverse, because it's quite easy to find the inverse. So after you've done that, you want to do the switch so that x is equal to y minus 5 over 2 squared minus 5 over 4. This implies that x plus 5 over 4 is equal to y minus 5 over 2. Let me square root that now. That implies that f to the minus 1 of x is equal to 5 over 2 plus root x plus 5 over 4. What is the domain of this function? Helen?
X is greater than and equal to negative 5 over 4. And it's one of the real numbers.
So without any working out, you just read it off of up there. Taking the range from here. And that's now the domain of the inverse function.
Sorry?
Yes.
How do you know it's plus, not minus inverse function?
Good question, really. Do a few questions in a row and you know which way around it is. It depends on how you restrict the domain. So there's no clear guidance on this question. It's not a well-formulated question as to what the domain needs to be restricted to. But if we took the domain in the other direction from the vertex, let's say we restrict the domain to x is less than 5 over 2, we would take minus the square root. And sometimes it's good just to check with the values, a value or two. If it's something more complicated. But put values in if you get two values. See which one works. Okay. Woo. Have a read through this, discuss this with people you like.
Okay, but
Stay silent if they're not here. No. After this question.
you have to write down the issue. You have to write down the
I shall pause the video. Get your calculators out, everybody. You got your calculators?
Mine was not on super
Mine always shows me that.
Mine is still.
The website, you plug in your directory, you go to the website.
You can try.
Just bring your computer to the tabs and plug in.
Connect it to another calculator that's on and go into document and press. Well, anyway,
So can we have that one?
and press document 9.1. Okay, calculator's on.
Plug in my calculator first, yeah.
Calculator's on, let's graph this. We need 0.0. How many zeros do we have? 1, 2, 3, 4. 1, 2, 3, 4. X to the power of 3. Is this a straight line? No. It just zoomed in too much. We need to adjust the y values because we're timesing by 1/100,000th. So let's add that here on the window settings. So here on the window settings, let's change the y values to minus 0.00 to 5 or so. We can see the graph looks like this.
It's mine. Yeah, I left it. That's good.
Unusual they get claimed. They usually just get left for good.
Well,
So the graph looks like this. What can we? Is this invertible?
Yes.
Is it invertible for all x?
No. Yeah.
yeah, because it just
It passes this.
Oh,
It
was it possible?
Because it's.
yeah, because it doesn't really. Actually, no, it's not. It's 3 0.
But that's a multiplicity. It's still
That's a
multiplicity.
multiplicity.
Good thinking. Good thinking, both of you. So yeah, this function is invertible for all x. Almost. However, we have a problem. This has a context. So
It can't be negative. The length can't be
It
negative.
can't have negative mass.
Or length.
so what is the domain of the original function?
X is 0 or bigger.
Why is the domain restricted by the question?
Because they can't.
Anas, because length can't be negative. No, mass. Yeah, length, sorry. Length can't be negative. So what we need to do is to find the inverse of this, and we've got this. We're not going to switch x and y because that makes no sense. We can't use that technique for this question because m and l mean something. M means mass, L means length. These things mean something. So we're not switching them for x and y. We're not switching them around. We just rearrange it as it is and end up with the function that we want. Because we're not defining the functions in x. Look at how the functions are defined. This is m of L and this is L of m. So you just leave them where they are as they are and just move it around. To help us move it around, I'm going to write this one in 1, 2, 3, 4, 5. So this is 1 times 10 to the minus 5 times L cubed. That's in standard form, isn't it? I have to move the decimal point 5 places to go from 1 to this number.
Why do you have to do 1 times? Like you just, I mean,
Standard form always. So standard form is always a times 10 to the n, where n is a integer.
it can't be 10 to the
And
1.5.
a is between 1 and. Sorry.
1
No.
1 10. It can be 1, but it can't be 10.
Yeah. so standard form looks like this, doesn't it? Although my natural number thing here looks a bit bad. It doesn't have to be a natural number, that's actually rubbish. It has to be an integer. There.
It couldn't be 0.
N can't be, it has to be an integer. So to move this to the other side, we get 1 times 10 to the 5. M equals L cubed. So L of M is just the cube root of that. What is the domain of this function? We just fix that. So this function is L, 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 and the domain of this function is M, M, M. That's the domain. That's it for that one. Some other little bits and pieces.
Sure. Couldn't you cube root the 1,000?
Okay, I'll include this in the video. Okay. So this is extension work. We want to cube root this number. Can I do it?
No, I had a question about the previous question.
Can we come back to that one? Write it down so you don't forget it. Or give yourself enough. How do we do this without the calculator? Let me show you.
Count the 0.
You make it a cube look between cubes split.
Just, I know.
What?
Yeah, then that's just.
Why is true?
Oh,
That's just.
that's because I forgot it. So we could rewrite it like this, can't we?
Yeah.
So it's 10 times the square root of cube. So 10 on the outside, right?
That's as far as it'll go. That's as far as it'll go. It's about 45, 46.
What's that? Oh.
Zinedine, you had a question.
Oh, yeah. For the previous question, wouldn't it be, instead of, what was it, 1 times 10 to the power of negative 5m, wouldn't it be m divided by 1 times 10 to the power of negative 5? Because when you rearrange it.
Notice I've changed the sign from -5 to +5. So I put it into the denominator, and then I moved it up by changing the sign. Actually, I did. I'm like, what will cancel that out? Cancelling that out would be timesing by 10 to the 5. So I times both sides. So I didn't cancel it by dividing, I cancelled it by multiplying, by the reciprocal.
If we didn't make it instead of -5,
So it's lack of understanding. Alex,
So the left is like 1 times 10 to the power of 5. So should we leave it like that? Or
Yeah.
should we?
that's acceptable. So numbers on the calculator in standard form. Notice this number here. What is this number here? 5e minus 5. On the calculator, it says 5e minus 5. This is how the calculator writes 5 times 10 to the minus 5. We can do calculations with these type of numbers here on the calculator. 5 and this button here next to the A. This is how the calculator writes them. So if you see something come out, sometimes you might do like an N solve, and it'll come out as 1.3567 whatever, and then it'll say E minus 23, because it's not quite found the right answer, because the answer is supposed to be 0. It's a numerical method that might cause an error on that. But watch for those E values coming out in your answers. If your calculator slipped into, sorry, your calculator is in one of, I can't get this right, document 7.2. So this number is going to come out of the calculator like that. I put it into flow 12 to force it to actually show it. You can force it to show standard form as well. So if we put a number like 30, and do 32, like this one. If you want it to show the standard form, you go into document 7.2, and you have the exponential form, scientific. Oops.
Is that in here?
No, I thought it was scientific, but maybe just see document 7.2. No, 32. Can't get it to do it. No, I thought it was that. That's it for me today. I'm done. Sorry, couldn't get